the combined gas law. This law combines the other three laws, Boyle's law, Charles's law, and Gay-Lussac's law. And it can be summarized as that P1 times V1 divided by T1 will be equal to P2, V2 divided by T2. So there are lots of variables. It's very important when you do these problems that we take our time and figure out what all the variables are. So let's look at this problem. We have a volume. We're given a volume is equal to 675 milliliters. We're given the temperature is 35 degrees C, and I'm going to go ahead and add that 273 to it. You must change all of these to Kelvin, or the equations won't work. And a pressure we're given of 646 millimeters of mercury. And the question here is, what is the volume? So we don't know what that volume is. If the temperature changes, and now it's minus 95 degrees Celsius instead of being 35. It's pretty cold. We're going to add 273 to it, and we'll get 178 Kelvin as the temperature, 2. And we have a new pressure as well. And our new pressure is 802 millimeters of mercury. Okay, so the problem we're going to be doing, we're going to be using this equation up here. And let's put ones by these. These are all our initial values. It's V2 is what we don't have. This is the one we'll be solving for. So in order to solve for it, we want to get V2 by itself. If we divide both sides by P2, and we multiply both sides by T2, we'll see that this one cancels this one, and this one, I'm sorry, erase. The P2 cancels the P2. And V2 is left by itself. So I'm going to rewrite this down below. I've got V2 is equal to, and I'm going to be writing all these letters and numbers. So we've got T2, P1, V1, and then on the bottom we're going to be dividing by P2 and T1. So now we just need to substitute in. T2 was 178 Kelvin. P1 is 646 millimeters of mercury. And V1 is 675 milliliters. And then we need to divide by P2, which was 802 millimeters of mercury, and by T1, which is 308 Kelvin. Now we can check our units here. We've got Kelvin on top and Kelvin on the bottom, so those will cancel. We've got millimeters of mercury on the bottom and millimeters of mercury on the top. So we're going to be left with milliliters as our answer, and since we wanted volume, that's a good thing. If we take our 278, multiply it by 646, multiply it by 675, and then divide by 802 and 308, we should get 314 milliliters. So let's do one more. Here we have a sample of helium gas. It has a volume of 0.180 liters. We have a pressure of 0.800 atmospheres and a temperature of 29 degrees C. We're going to add the 273 to it. We do for all of our problems, and we get 302 Kelvin. Okay, at what temperature? So we don't know our secondary temperature is going to be, that's what we're trying to find out. These are our ones. At what temperature will the helium have a volume of 90 milliliters and a pressure of 3.20 atmospheres? Okay, I hope you've noticed that there's a problem here. On this side, I've got volume in liters. Over here, volume is in milliliters. These have to match. Doesn't matter if I go to milliliters or if I go to liters, but they need to be the same. I think I'll divide this one by 1,000, and that will give me liters. 0.090, keep all my significant figures right, liters. We've just moved the decimal 3 places to the left to change it from milliliters to liters. Okay, so let's look at our problem. We've got P1 V1 divided by T1 is going to be equal to P2 B2 divided by T2. Okay, T2 is what I'm looking for. This is what I don't have. I've got all these other variables. That's the only one that I don't have. And it's on the bottom. So I'm going to begin my process by cross-multiplying. We're going to cross-multiply. That'll put the T2 over here and the T1 over here. So we'll put T2 P1 V1 is equal to P2 B2 T1. All I've done is cross-multiply and gotten the variable that I'm interested in off the bottom, because it's very difficult to solve it that way. Now, we want to get T2 by itself, so I'm going to take over here and I'm going to divide by P1 and V1. Here, I'll divide by P1 V1. That will make, I'll do the highlighter, that will make these cancel and these cancel, and I'll have T2 is equal to P2 B2 times T1 divided by P1 and V1. And then I can just substitute in. Let's get rid of the highlighter. P2, let's put 2's by these, I didn't earlier, is going to be our new volume, our new pressure. It's going to be 3.20 atmospheres. Our new volume is going to be 0.09 liters. And our initial temperature was 302 Kelvin. Then that gets divided by P1, which is 0.800 atmospheres, and V1, which is 0.18 liters. So let's look and see which units are going to cancel. We're going to get rid of atmospheres because we've got it on the bottom and the top. We'll get rid of liters because we've got it on the bottom and the top. We're going to be left with Kelvin, which is good because we're looking for a temperature, right? So it looks like it's working out. We'll get 604 Kelvin. We do the math on this. We'll need to subtract off 273 to get our Celsius number of 331 degrees Celsius.